Hello, today we will continue to discuss descriptive statistics, tabular and graphical displays, but now we will have two variables at a time. We will discuss summarizing data for two variables using tables, summarizing data for two variables using graphical displays, and we will discuss the data visualization. So, how can we summarize data for two variables using tables? We can use cross-tabulation. And cross-tabulation, you can use the cross-tabulation when both variables are categorical, when both variables quantitative, and if one variable categorical, the other variable quantitative, you can use cross-tabulation. So often the manager is interested in tabular and graphical methods that will help understand the relationship between two variables. So now we will focus on the two variables. Previously we discussed one variable at a time. So then here we have two variables, so the left and top margin labels define the classes for the two variables. So this is one example. Here we have two variables, price range and the home style. We have two classes for price range, less than $250,000 and larger than equal to $250,000. And four different home styles, colonial, log, split, A-frame. And what are the insights we gain from this cross-tabulation? So such as we have only three A-frame homes larger than equal to $250,000. Largest number of homes sold is split, 35 total number of homes, split style homes sold. Total we have 100 homes and 55% less than 250 and 45 of them larger than equal to $250,000. These are the insights we gain from the cross-tabulation. And the cross-tabulation, this is the frequency distribution. So the row and column totals are the frequency distribution. So this is the frequency distribution for the price range variable. So we have 55 homes less than $250,000 and 45 homes larger than equal to $250,000. And this is the frequency distribution for the home style variable. So 30 colonial, total 20 log style, 35 split, and 15 A-frame. We can also obtain row and column percentages to gain additional insight about the data. Now, how do we obtain the row percentages? For this example, now we have total 30 colonial homes. 18 out of 30 less than 250. So what percentage of colonial homes less than $250,000? 18 out of 30 times 100%. Now this is this is row percentages, not the column. So then row percentages. So now we look at the row totals. So 55. So total 55 less than $250,000 homes. And now what percentage is colonial? So we only focus on this less than 250. What percentage is colonial? What percentage log? What percentage split? And what percentage A-frame? So then it is 18 out of 55 times 100%. So first we will obtain the row, then we will look at the column percentages, which is 32.72%. And what percentage is log style? So we look at less than 250, which is now 6 over 55 times 100%. Which is 10.91%. And what percentage is split? 19 divided by 55 times 100. .55%. And what percentage is A-frame? 12 divided by 100 with 12 divided by row, total 55 times 100%, which is 21.82%. And the sum of these percentages, which is 32.72 plus 10.91, must be 100. And this is 100. Now what? So now we look at larger than or equal to $250,000. So then 12 out of 45 is colonial times 100%, which is 26.67%. 14 divided by 45 times 100%, so it is 31.11%. 16 divided by 45 times 100, which is 35.56%. 3 divided by 45 times 100, 6.67%. And the row total must be equal to 100%. It is little off due to rounding. And now we can obtain column percentages. So we have, now we will obtain column percentages. So we look at the colonial home. Total 30 colonial homes, 18 of them less than 250, and 12 of them larger than or equal to 250. So what percentage of colonial homes are priced less than 250. So which is 18 over 30 times 100%, which is 60%. So then if this is 60, then this will be 40%, which is 12 divided by 30 times 100. So the total must be 100. And now the log style, and it's 6 divided by 20 times 100%, which is 30%. If this is 30, then this is 70%, which is 14 divided by 20 times 100. And the split, 19 divided by 35, 54.29%, and 16 divided by 35, 45.71%. And now we look at the A-frame homes. We have total 15 A-frame homes, 12 of them less than $250,000 and 3 of them larger than equal to $250,000. So what percentage of A-frame homes less than $250,000? 12 divided by 15, 100%, which is 80%. And if this is 80%, then this is 20%. These are the row and column percentages for this example. And why do we obtain the row and column percentages? To gain additional insight about the data. These are the column percentages. Now we will discuss the Simpson's paradox. So data in 2 or more cross-tabulations are often aggregated to obtain a summary cross-tabulation. But if we look at the aggregated cross-tabulation and unaggregated data, the conclusion may be totally reversed. So the reversal of conclusions based on aggregate and unaggregated data is called Simpson's paradox. And we will look at this example to provide an illustration of Simpson's paradox. So there are 2 judges, Judge Lockett and Judge Kendall, presided over cases in common pleas court and municipal court during the past 3 years. Some of the verdicts they rendered were appealed. In most of these cases, the appeals court upheld the original verdicts, but in some cases, those verdicts were reversed. For each judge, a cross-tabulation was developed based on 2 variables, which verdict upheld or reversed, and judge, 2 judges, Lockett and Kendall. So this cross-tabulation shows the number of verdicts upheld and reversed for both judges. But this doesn't show the type of court. We have 2 courts, municipal, common pleas, but this is the aggregated cross-tabulation. If we look at this aggregated cross-tabulation, 88% of the cases that Kendall's cases upheld, and 86% of the Lockett's cases upheld. And if we look at this aggregated data, Judge Kendall is doing better, and a greater percentage of Judge Kendall's verdicts are being upheld. So based on this aggregated data, Judge Kendall is doing the better job. But now if we look at the unaggregated data, here we also see the type of court. 85% of the Lockett cases upheld in the municipal court versus 80% in the Kendall. And here 91% upheld for Judge Lockett in the common pleas scored, and Judge Kendall 90% upheld. So if we look at the unaggregated data, Judge Lockett is doing a better job. So now this reversal of conclusion based on aggregated and unaggregated data is a Simpson's paradox. So this shows the Simpson's paradox, this reversal of conclusion based on unaggregated and aggregated data. If we look at the aggregated data, we conclude that Judge Kendall is doing better. If we look at the unaggregated data, Judge Lockett is doing better. So reversal, so the conclusion totally reversed. Because of the possibility of Simpson's paradox, so they realize that the conclusion or interpretation may be reversed depending upon whether you are viewing aggregated or unaggregated data. So before drawing the conclusion, you may wish to investigate whether the aggregate or unaggregate form of the cross-tabulation provides a better insight and conclusion. And especially if the hidden variable affect the results, such as here the hidden variable is type of chord, which it affect the result. So you should look at both aggregate and unaggregated data before drawing a conclusion. Now we will discuss summarizing data for two variables using graphical displays. And we will discuss scatter diagrams and trend lines, which you can use the scatter diagrams and trend lines to explore the relationship between two variables. Scatter diagram is a graphical display between two quantitative variables. And the trend line provides an approximation of the relationship. This is a positive relationship. What do we mean by positive relationship? The slope is positive. If one variable increases, so as x increases, y is also increases. So it's a positive relationship. And this is a negative relationship because as x increases, y decreases. And there may not be any apparent relationship. Now the slope is 0, no apparent relationship. Now how can we obtain the scatter diagram? Now x is the number of interceptions and y is the number of points scored. So you have two x's, x and y. Now so x is 1, y is 14. It's approximately like this point. X is 3, y is 24. X2, y 18. And x is 1, y 17. Approximately this point. X3, y 30. This is the scatter diagram. Now what can we say about the relationship here? It's a positive relationship. So higher number of point scores are associated with higher number of interceptions. And here it's not a perfect relationship because not all the points are on the trend line. And we will also discuss the numerical measures of association. We will also discuss the relationship between two variables, numerical displays, which is covariance and correlation coefficient. Other graphical displays are side-by-side bar chart. For example, for Finger Lakes Home, this is a side-by-side bar chart. Here we see the colonial home and two different price range, less than 250 and larger than 250. For each home we have two different price range. That way we can compare those. Stacked bar chart is another graphical display. Now in this case we have one bar for each home style, but different colors. Like here, this is less than 250 and this color represents the larger than equal to 250. One bar chart for each home, but gives the frequencies. This height gives the frequency for each color, for each price range. And this is the percentage frequency. So it's 100%. Now you can see what percentage is colonial. So 60% colonial, then 40%. So for the colonial home style, 60% less than 250 and 40% larger than equal to 250. This is a stacked bar chart. So that we will briefly discuss the data visualization. Data visualization is the use of graphical displays to summarize and present information about a data set. And the goal is to communicate as effectively and clearly as possible the key information about the data. And there are some guidelines to create effective graphical displays, such as give the display a clear and concise title, keep it simple, if colors are used, make sure they are distinct, clearly label each axis and provide the units of measure. And here we discuss variety of graphical displays in this chapter. If you wish to show the distribution of data, you can use bar chart, pie chart, dot plot, histogram, stem and leaf displays, depending on whether you have categorical or quantitative data. To make comparisons, you can use, if you have two variables and you wish to make comparisons, you can use side-by-side bar chart, stacked bar chart. And to show the relationship, you can use scatter diagrams and the trend line. This is the summary, shows which display to use. And we will now briefly discuss data dashboards. Most commonly used, the most widely used data visualization tool is the data dashboard. And if you drive a car, you are already familiar with the concept of a data dashboard. In the car, the car's dashboard contains gauges and other visual displays that provide a key information that is important when operating the vehicle. For example, the fuel level, speed, the oil level, these are the critical information to ensure safe and efficient operation of the car. And the dashboards play a similar role for managerial decision making, which is so data dashboard is a set of visual displays that organize and presents information that is used to monitor the performance of a company or organization in a manner that is easy to understand and interpret. And every business has key performance indicators that need to be monitored to assess how a company is performing. And also, it organizes and presents the key performance indicators used to monitor an organization or process. There are some guidelines to create effective dashboards, like minimize the need for screen scrolling, avoid unnecessary use of 3D displays and color, use borders between charts to improve readability. This is one example. And in this chapter, we discuss a variety of graphical displays, including bar chart, pie charts, dot plots, histograms, stem and leaf plots, scatter diagrams, side-by-side bar charts, stacked bar chart. Each of these displays was developed for a specific purpose, and this is a guideline to show you which graphical display to choose. Now we will discuss one example. Now here, data showing the quality rating and typical meal price collected for a sample of 300 restaurants in Los Angeles area. Now how can we summarize this data? We have two variables, meal price and quality rating. So we would like to, such as quality rating, meal price. How many different quality ratings do we have? We have good, very good, excellent. And the meal price, now the meal price is quantitative. Now we need to determine the class, number of classes, the weight of each class, lower and upper limits of each class. In this case now, let's see the range of the data. What's the minimum? Minimum is 10 and the maximum meal price $48. Now we can do the $10 increments like 10 to $19, 20 to 29, 30 to 39, and 40 to 49. Now the question is now, how many do we have in this price range? And good quality rating, so good, and in this price range, 10 to 19. How many do we have good quality rating and in this price range? So we cannot manually count this, it will take so much time. Now how can we use Excel to summarize this? Now we go to Insert, we select the data, the entire data, go Insert, Pivot Table, so data is already selected here. You can either do Insert, Pivot Table, and come here, select the data, or first select the data and then go Insert and Pivot Table. Now we can do existing worksheet, or you can put it in a new worksheet. Say new worksheet. Now here, what is our column variable and the row variable? Now here you see the row, columns, percent values. Now whichever variable you selected as a row variable, you put it in the row. We selected quality rating. So as you see here we have excellent, good, very good as in the row. and the meal price column variable, so we drag it the columns. As you see, we have meal prices. But now we come here, value, we bring the restaurant into the value. Now it looks like this. It looks weird now because it sums the restaurants, but what do we want here? We don't want it to sum. So we click here, value field settings, count. We wish to count the number of restaurants. And now still, like, this goes $1 increments, like 10, 11, 12, 13, 14, 15. We want a $10 increments. So then we come here, right click, and then see here group. We come group 10 to 49 by 10. And it's okay. Now as you see, this is summarized, and also you can move this excellent to the end. So good, very good, excellent. And you can use this to obtain row percentages, column percentages, or you can such as select this data and insert. You can obtain side by side bar chart. So that provides, so it is to summarize the data. If you have large amount of data like this, you can easily use, and you wish to obtain the pivot table, you can easily use the Excel to obtain the pivot table. And in reviewing the table, we see that the greatest number of restaurants in the sample, which is 64, have a very good rating, and the meal price in the 20 to 29 price range. And only 2 restaurants have an excellent rating and a meal price in the $10 to $19 price range. And these are the insights we gain from these summaries.